go ahead and start recording. All right. So, hello everyone. Welcome to the webcast, working with SSH. Today we're going to be working with some introduction to SSH and its features. And I was just talking in chat there about the name, which is I'm managing my servers. So it started out with a mistype. Kevin had mistyped the name when he put it into the GoToMeeting training. And then when I mentioned it, hey, this doesn't quite fit like it should. So he went in here and made a correction and mistyped it. And so then we started laughing about it. And that's how the name of the course ended up the way it is. Shh, I'm managing my server. So that's where we're going to start today. Okay, so starting off today, my name is Bill McCauley. And today we're going to go through just some basic overview. And the idea of this is not necessarily for people who are looking for advanced SSH techniques. One of the reasons that this course got generated to begin with was we were discussing options for webcast ideas. And the idea came up, well, what about SSH? And I believe it was Kevin, it might have been someone else had mentioned, you know what? I've been doing SSH forever, and I forget there's people out there that don't know things about it. And so we decided to do this. And when I started doing this, when I started doing system administration type work, a lot of the things that we did were telnet, a lot of the things we did were rlogin. So we would do the connections, but because we did a lot of legacy type equipment, it wasn't secure communications between the two. And so that's some of the ideas that we want to cover. We want to go through, give an idea of what it is. We want to look at some of the basic setup options because you've got a lot of setup options these days that in the past you didn't have. We'll look a little bit at key pairs, secure copy. We're going to spend some time on the SSHD options. This is where your server configurations are going to be. And then after that's all done, we will move to the laboratory. We're going to go through and take a look at a lab, and we're going to just walk through a few basic examples. Now, because of the amount of information that is available for SSH, I had to dial it back. I had to cut out like half of the information just because there was too much to be able to fit within a 1 hour time block. So I've tried to cherry pick some key examples that will highlight some of the functionality that SSH can do, whether we use those on a daily basis or not. And then to kind of top that off toward the end, the big highlight of this is going to be picking apart the local and remote forwarding. Because when I first approached local and remote forwarding, when you set up your SSH tunnels, my brain got twisted up trying to understand what was where, what connected to what, why this port was here, and how those things got bound together. So we're not gonna go into super depth, but I want to point out context, because when you're dealing with your SSH tunnels in particular, context matters. So where you start, where you're going from, where you're going to, those are the things we want to pick apart to maybe, hopefully for somebody, demystify how those tunnels work and where the connection points are taking place. So with that, let's jump into the basic, what is SSH and why is it used? So in a nutshell, SSH, or secure shell, is going to be a protocol. People think of SSH in two different terms. One, you're thinking of a client software, or two, you're thinking of the protocol. And for people who are just getting into this area, a protocol, in essence, basically explains what to do and how to do it. In essence, that's what a protocol does. So your SSH protocol is going to specify, it's going to define how those communications are handled over a network, how to secure, how to encrypt that data from host to host, from one machine to another. And for software-wise, you're dealing with just a program that's going to be used to create that remote encrypted connection. So it's going to use secure shell, it's going to use the SSH protocol, and that's what's going to create your connections. In Linux, you're going to have your SSH terminal, you're going to have your SSH commands, whereas in Windows, you may have something like PuTTY or MOBA Xterm, something of that nature. And one of the reasons, slightly alluded to this earlier, is one of the reasons that SSH was was created in the first place was to replace those unencrypted connections, because when in the past, when we would do our server administration, our remote administration, we could remote to those machines, but any traffic, anything that we did was in clear text. And so anyone who had access to listen on that network, they could see credentials, they could see data, and depending on the type of data you're dealing with, that's not a good thing. And so SSH was created to create that secure tunnel, to use those encryption algorithms to make sure that from point A to point B, that traffic is secured so that only the destination, the source and the destination can be able to access those from there. Okay, so with that, and I'm not going to spend a whole lot of time going through the setups, and not a whole lot of time going through some of the background, mainly because I know that once we get into the lab section of that, it's going to take time to really go through each of those sections. And so, in a nutshell, Windows 10 in particular has provided the option to enable OpenSSH, to install an OpenSSH client and server in Windows 10. And I've got the instructions up here and want to do it. The part that I want to highlight about this is right here, that this took me a while to find. And so if you're going to install SSH, you would go apps and features, look for your optional features. If it's not already there, add the feature, click it, and install. Very quick, fairly easy. I believe you have to do a restart after that. I can't remember exactly right now off the top of my head. But the idea is here, once you got your SSH server, this is going to be the path for your SSHD config. And this is going to deal with your server configuration options, which has a different naming convention than Linux does. Just one thing to be aware of right there. One other note is you're going to notice SSH versus OpenSSH. SSH is going to be the protocol. This is going to be the instructions on how to encrypt. OpenSSH is a suite of tools. That's a utility, a set of utilities that is built on that SSH protocol. So just to keep for people who are just getting into this, a differentiation between SSH, which is the protocol, versus OpenSSH, which is a suite of tools. Okay, so in Windows 10 recently, there has also been, let's see, how long has this been out for? Since, I want to say at least since last year. It's been a little bit. When they were first trialing this, I kind of stayed away from the Linux subsystem just because I wasn't sure how it was going to interact with Windows. But we have a guy who uses Hyper-V, and in the beginning, there was a lot of issues between using his Hyper-V instances and using a Linux subsystem on his machine there. But just to be aware that when you enable this, you're going to have two reboots. You're going to go to your settings, update security. You can read through this. You'll have to reboot at that point. When you come back in, you're going to have to go to your control panel program. There's other ways to get to this settings area for your turn Windows features on or off. This is just typically the way I do it. You'll enable the Windows subsystem for Linux, reboot, and then you're going to have another step. And so this is where, when you enable the subsystem, you've got the ability to use it, but you're going to have to go to the Microsoft Store in order to do a search and find a subsystem. And if you go in there and do a search for just Linux subsystem, you're going to come back with Kali, you're going to come back with Debian, Ubuntu, you're going to have Fedora, you're going to have a good choice of distros that you can choose from. Not everything is up there, but you should have at least a decent set of options as you can choose from. And then when you're ready to actually use it, just open up your Windows menu, type in Linux, and whichever distro you selected, that's what'll pop up in there. So just a few notes about how that is, how that works, and where it goes. Okay, let's look next. And for Linux, typically pretty straightforward. If any of you do any sort of Linux administration, this should be old hat for you. So in a nutshell, you're just going to do an apt-get install OpenSSH server. If it's not already installed, it will install the server and typically the client as well. But most of the time, Linux is going to come pre-installed with at least the SSH client, if not also the SSH server as well, for Open SSH server. You can also look at the cat etc ssh sshd config location. You can look for your config file to see if it's there. You can also do a ps-ef, and you can look for your sshd service. Also, if it's not running, just make sure that you've got the service started. So not going to spend a whole lot of time on these couple slides, but just pointing this out, so if anyone wants to come back and install this, there's at least something they can look at and don't have to go looking someplace else for it. Okay. Keys. So in Linux, or I shouldn't say Linux, but in SSH, you have the option to log in with names and with passwords and with keys. And you can set passphrases on those keys. The idea here is when you're setting up your accounts, there's an option for doing a public-private key pair. Now, what this is going to do is the public key cryptography is going to use algorithms to create a pair of keys that match, basically the way that a lock and a key will match. And if you have the correct key, you can open the lock. In our case, for our usage of this, the application of this is, for us, the public key is going to be on the machine we want to connect to. So when we connect to it, that's going to provide the encryption. That's going to encrypt the data. That's going to allow that to happen. And the private key is going to be your authentication so that you have access. If you've got the correct private key that matches with the public key, then you can authenticate to that machine and you can access the data that's been encrypted there, or to create that tunnel for passing data back and forth. So in a nutshell, that's what the keys will do. There are a couple different ways to do the keys. Thinking of Windows and PuTTY, this will be a third-party application, and PuTTY is going to be one of the software tools you can use that will create your SSH connection. But PuTTYGen is what you're going to use to generate your key pair. Now, one thing to note that I wanted to make a note about this is when you create your public and private key, your public key can go anywhere. You can lock down your access, your authentication. You can put it on other machines. You can send your public key wherever you want to send it. But the private key of this, you want to keep that safe. And when you're creating your private key, there's an option to do a passphrase. Now, if I'm working in a corporate environment and I've got multiple machines that I'm connecting to, but I have no passphrase on my private key, then if someone were to happen to get into my account and get access to my private key without anything else other than having that private key, they could access anything that I had access to touch. And so that's one reason you want to keep that private key safe. That's the key to open those locks, and you want to make sure that that's kept someplace safe. When you're generating your key in PuTTY, if you go to save that private key without giving it a passphrase, it'll pop up a warning saying, hey, is this really what you want to do? Now, best practice, again, put a passphrase on it. Put something to lock it down so that even if you lose or someone else gets a hold of that key, there's another step, there's another layer of security that goes around that can stop somebody from just using it at will. And in Linux, pretty straightforward, ssh-keygen. We're going to do a few of those later on, so I'm not going to worry too much about it right now. The only other piece that I wanted to mention is the location. And in Linux in particular, most of this is going to focus towards a Linux system from here on out. You're going to have a known host file, and you're going to have an authorized keys file. And so anytime that a user creates their keys, only the user should have access to that information. And so the user is going to have their home user directory, and then underneath that, there should be a .ssh folder. If it's not there, they can make it. We may have to make one here in just a little bit, just from the systems that we're using that we spun up from my default lab here. So the known host will contain the fingerprint of each of the SSH connections that you make. For example, if I'm on VM2 and I reach out remotely through SSH to connect to VM1, there's going to be a fingerprint. It's going to say, this is the machine you're connecting to. Here's a fingerprint of that. We're going to store it in my user's known hosts. It doesn't get stored in every user. If I'm connecting with one user account and I go out to machine, the fingerprint of the machine I'm connecting to is the one that gets stored in my known hosts. The flip side of that is going to be your authorized keys file. And that's going to contain the public keys for people who are allowed access. For example, if I push my key out to VM1, then once I provide the initial authentication, showing that I've got the password to connect there and to push my key out, that public key that I sent gets stored in the destination user's authorized keys, so that when I connect, it'll first look for, do I have a matching key? And if it's there, it'll let me access without having to provide anything other than my key and my passphrase. So that would be, in a nutshell, just an overview of the public-private keys and the pairs, and how to generate them in both PuTTY and Linux in particular. All right. Now for the fun stuff. Okay. So when SSH is set up, when you've got a server set up, it's split in, so SSH is going to be split into two modes. You're going to have a server mode and you're going to have a client mode. There's going to be an SSH_config, which is going to deal with user configurations. And then you're going to have an SSHD_config file that is going to deal with your server config file, or server SSH settings. So, and what I've done here, there are many different options that are under this SSHD config file. And what I wanted to do is I just wanted to pull out a handful of these, just because the time it would take to go through all of them, we just don't have that time today. So when you, and this is where I'm going to pull up, let's use our jump box as an example. All right, so default location, cd, etc, ssh, sshd. I got to put the slash at the beginning. There we go, ssh, sshd. Sorry. I'm going to my directory, and then I'm going to, let's do sshd, and you can laugh, yes, I'm using sudo, or using nano. I know I've got Alex and a few others that are going to give me grief about that, but that's all right. Okay, so one of the first configuration changes you can make, and the way this file is going to work is this. There are different options you can set. And if I wanted to change the port for this, as a simple example, I would uncomment this. Now, just because some of these are commented out by default here, does not mean that SSH is not using port 22 already. So there are some things when the SSH server is configured, by default it's going to use, and this port 22 is one of them. So you have the option to change this to something like 8022, which we're going to look at later, and I'm just using this as an arbitrary number. And what you would do is, once you save that, you would restart your service, go back in there, and now your SSH is going to be running on port 22. Now I want to bring this up because there has been, while using obscurity on top of, we had a conversation about this earlier this week, using obscurity on top of security is not a bad thing. If you're securing something and then putting some obscurity around it, that's great, that's fantastic. But if you're only changing the port number, and then saying, well, that makes it secure, that would be an incorrect assumption. And what happens is, for example, can't type in, there we go, okay. For example, if I were to change that default port and then from an outside machine just do a simple nmap scan, it's going to return a list of open ports. And it's not going to see port 22, but it will see port 8022. And if I use something as simple as telnet to the IP on port 8022, I'm going to get an interesting response back that says, hey, this is the SSH version. And so simply by doing a little bit of reconnaissance on whatever open port this happens to be, you can very quickly identify that this is the SSH service that's being run in. And so if anyone is doing recon, something like this would not stop them. Now, if you have good business reason, if you had justification for this, or like we have here, if you have a lab that you just want to test things out, go for it, have a great time with it. The idea is just don't think that that's going to be your security measure, because that's not going to be sufficient. Okay, so let's go down to next one here, address family. Address family, okay, so here's what the address family option will do. By default, this is set to any. And what this means is, if you're listening for traffic that is IP version 4 or IP version 6, any would take care of both. If for some reason you only want your SSH traffic to be listening for IPv4, you're going to set this to something like iNet. So you're going to have iNet. If you want to change it to IPv6, you'll put it to iNet 6. But for our purposes, setting it to any so that it listens on both is a good thing to do. I'm trying to think off the top of my head if there's any business use case that would warrant changing it to IPv6 or 4. I can't think of a specific example now, but if you needed to listen for just one type of traffic, then you would have the option to set that there. Okay, so the next one. This one, I like this one. So what this one does is, for your listen address, by default, this is going to be set to 0.0.0.0. And what that means, 0000, is listen on all available addresses. And that includes virtual addresses. That includes Wi-Fi. That includes hardline. So if you've got virtual network adapters, if you've got your Wi-Fi turned on, if you've got your Ethernet adapters, it will listen on all available addresses. And the place where this particular setting really comes into play is, let's say, for example, on my jump box. If I've got, here, let's do it this way instead. If I've got IPA 192. So if I'm on a jump box that has multiple adapters, if I've got a box that spans multiple networks and there's multiple network adapters on those networks, this would allow you to set one of those to listen to. So let's see, we've got 77.53 and a 78.53. If I come down here and change this so that I only want my SSH traffic to go across 192.168.78.53, only that adapter, that's what I would set it to. Now, be aware that if you do this, SSH traffic will only work on this port, meaning if I try to connect to 127.0.0.1, that's the same local machine, yes, but it is a different IP address. And so when you specify that listen address, then it will listen only on that one address or whichever addresses you happen to put in there. So just a note that you can specify, specifically when there's more adapters, only listen on a specific host, or I'm sorry, only listen on a specific IP for SSH traffic. Okay, let's hop down here to this red flag right here. PermitRootLogin. So, sorry, I'm moving some things around on a different screen, and it's adjusting. There we go. I've adjusted now for my GoToMeeting control panel. All right, PermitRootLogin. Here's what this does in a nutshell. Root login allows the root account to remotely connect using SSH. The default prohibit, you gotta spell it right, prohibit password. The default is this. The options are I can set it to no, meaning that no login, no remote login by the root account can happen. I can set it to yes, saying that a root account plus a password or a root account plus a private key for key authentication, that will work. It'll take both. Prohibit password is the in-between. It's the one that hits in between those two options and says you can only connect with a root login if you're using the public and private key authentication. So just a note on this, because in some of the tests we've done, we've gotten root access on a machine and been able to, from there, we can navigate through the rest of the network. Because once you've got an account like this, typically, and we're going to see this later in an example, typically that account and password, that account and credentials are the same everywhere, right? Those things don't get individual by machine. It's the same set of credentials everywhere you try to go. So the default permission here, best practice, what it should be is no. For our example, we're going to leave it on yes for now, just because this is a test. And this is why it's nice to have a lab like this that we can set this up with. Okay, password authentication, very quick, very easy. Password authentication will allow name and password. If you set this to no, this will force key authentication. This will force you to have a public and private key pair in order to do this. Permit passwords, this typically only works with the password authentication. These two work together. And if you're going to use password authentication, make sure the empty passwords are set to no. You do not want empty passwords across your network. All right, so we have 3 types of forwarding here that I want to look at very briefly. The first one, AllowTcpForwarding. By default, this one is set to yes. And what this does, this is just going to allow the users to be able to, this is going to allow port forwarding. If you've got it set to yes or got it set to all, this is going to include all TCP forwarding. If it's set to no, it's going to prevent all TCP forwarding, which we can actually go through an example of that later if you like. Because this field, by setting this to no, will not stop a local or remote tunnel from being created. And I want to make that distinction. It won't stop the tunnel from being created, but it will stop me from accessing that tunnel locally or remotely. So that's one thing to note with this. Gateway ports, this kind of works hand in hand with the port forwarding, except that this deals with your remote or your reverse port forwarding. Remote, reverse, those mean the same thing for this, remote forwarding or reverse port forwarding for this. And so by default, this is set to no. And SSH, OpenSSH by default only allows you to connect to a remotely forwarded port from the server, from the host. By changing this to yes or even client specified, those are the 2 options. You've got yes, the other is client specified. So this will allow you to either specify a specific host to bind it to. You've got the bind address and the port, or set it to yes and it'll allow connections to the remote port forwarding from outside that server that it's created on. So gateway port forwarding, TCP forwarding, and again, these two will not stop the tunnel from being created. It will stop people from, especially this one right here, the TCP forwarding, setting that to no will stop people from being able to access it. But by default, unless you have a good reason for having this on, typically you want to have this off. The X11 forwarding is similar, where this will do forwarding, except what it's going to do is, this is going to forward graphical screens. This is going to do GUI information, and I don't have an example. I don't have an actual demo of this piece of it set up, but we use this piece quite a bit, where we're working inside of a network, and we want to proxy, we want to create a tunnel so that we can, because we're working on a command line, and we don't have any way to view the web page, and so we would set up a forward so that we can pull it up on a VM on an encrypted place here and be able to forward that X11, that GUI information, to a web browser inside of a testing box. So that would allow us to do RDPs. That would allow us to look at web apps, to actually visually and through a graphical interface interact with those things. So again, unless this is something you really need on, probably by default turn it off. All right. So the last couple are not by default in here. And I'm not going to go through too much with this other than to map these out. So we've got some options that you can add here. You know what? It'll be better if, see, I thought ahead and I brought myself some, I mapped this all out so I can just go boom, there it is. Ingenuity at its best. Okay, so these particular options were not in my default SSHD config. I don't think they're there by default on many. It might have been before, and that's an answer that I don't have right now. But you can add these in here as options. And real quick, if you're looking to secure, if you're looking to lock down who can use SSH, who can get to this machine using the SSH service, because the problem that we face is where you've got someone who knows a bit about networking, knows a little bit about SSH, and creates a tunnel outside the network, through the firewall, to an outside location, to their home machine, or reverse back in. And what you're trying to do is you're trying to restrict those types of things. You're trying to restrict the use of SSH to authorized personnel only. Deny users. So the way this works, and this, the way the, how do I put it? The way these are processed is in this order, as in deny users will be checked first, then allow users, then deny groups, then allow groups. If I have user 1 here and user 1 here, the deny group is going to override the allow group, meaning user 1 will not be able to connect. Okay? Works the same with groups. If you take the user 1's group and put it into the deny groups, allow groups, it will deny user 1 from being able to get into here. Now I got to erase all these. Okay, so what can you do with these, and what's the way you want to actually apply these settings? And here's what you'll want to do. If you've got specific users that you know that you never want to SSH into this machine, you can put user 1, user 2, user 3. You can set a list of deny users. You can put that in here. Those users will not be able to access this. If you've got specific users you want to allow, and I want to make a note here, for this particular setting, for allow users, it's an explicit, as in, if I've got user 1 here, only user 1 can access this machine through SSH. So this is going to be only allow these users. And that's good to keep in mind, because you may put a user, hey, I want this user, and then suddenly you can't connect because you're not that user. So be aware that the allow users will say only that user. Now groups will be the same. In fact, and allow groups, deny groups will work very similar to the deny users, allow users. So if you're doing good monitoring, good logging, good access controls, and you know who has access to what, you're keeping track of the roles, the responsibilities, what you could do, as an example, is you could create a group, no remote, no SSH, something along those lines that you would know, and by default you can say add this group to the users. So take that group, add it to the user, and then only that people that are in those groups, by default when you're creating the accounts, they won't have remote access unless you go in and manually give them access by removing that group from them. Now, another thing you can do here is if you've got a sysadmin, or if you've got, well, we don't want root because we don't want root to remote login, but if you've got a sysadmin, maybe a DBA, if you've got something you want to explicitly allow that everyone in the sysadmin group, that's how you can set those up as well. So I think that kind of beats that horse a little bit further. But if there's any questions there, I've got some notes at the very end of this on documentation. Let me change that. I don't want to save that. Okay, I've got some documentation at the end of the presentation here that will go through more of this, as far as where you can go for more information, if you're going to look up settings and some of the details around some of these different options that you can use. Okay, now let's hop into the laboratory. All right, so really quick, this is an overview of the network we've got set up. And by the way, I want to officially thank Alex, who we worked together to use a Vagrant file to spin up my network lab, spin it down to make changes. We've got a configuration file that we'll look at the very end of this. Thanks, Alex. I just saw him put a note in the chat. And so the way this is set up is here. We're going to have 5 total machines. I'm not going to bring all 5 of them up because just the 4 is going to suffice for what we want to do. But they're segmented. You're going to have a network A, a network B. Those two cannot communicate together, and you're going to have a jump box in between them. So we're going to look at a somewhat realistic configuration for this, for segregating these 2 networks, or having multiple networks with a box in between. Okay, so with that being the case, just a note on the IP schemes. We got a 77, 51, 52, 53. Then we've got a 78, 53, 54, 55 to kind of keep things organized for us. All right, moving on. Okay, so we're going to do some connections. And I'm going to leave this up for just a minute so that if anyone wants to take a look at it, just a quick look. And then I'm going to pull up all my screens to go over the details of this. Okay, let's pull these up. All right, let's rearrange this. So for what we want to do, we can probably pull this one down, this one down. Let's do this. Okay, here we go. You know, one quick note before I go any further. As far as the SSHD configs, if you're looking to also lock down your SSH server, there is an etc host.allow, and an etc/host.deny. There's a host.allow, host.deny file in your etc folder that you can use to specify IP ranges, domains. You can set those up to allow subnets or certain ranges of IPs to connect, and different specific machines by IP. So there's a couple other options. I meant to mention that earlier. All right, so let's first look at what we're looking at. Okay, let's look at our jump box, which is here, different machines. All right, so let's start with, let's ping from, let's go from VM2 to our jump box. There we go. Network is a little slow, but it's moving. Okay. Let's confirm that we can go from our jump box to our VM4, which is on our other network. IPA. Let's do a grep 192 just to keep it simple. We also have connections. So let's change this and see if we can get to, let's see if we can get from here to from our 77 to our 78 network. Unreachable, unreachable, unreachable. Let's try one more time, going to past the jump box to our VM4. Unreachable, unreachable. Got it. Just for confirmation. Now, let's move into, let's do this one, pull this over. All right. So, very quickly, let's take a look at our keygen. We're going to go from SSH. I take that back. We're not going to do keygen. 192.168.77.51. So this is where it's going to ask us for our fingerprint. Initially, we're going to say yes. This is going to get stored in my known host because I've connected. Now you notice that I did not put a user account here, and therefore it's assuming that the user account that I'm currently logged in as is the same user account on the other machine. So if I have that, and if that account exists, it lets me in. Hostname. Okay, so pretty straightforward. Going to our next example. If I were to connect, let me copy. Let's do this. If I were to try to connect from VM2, let's use our VM2 user account. So what this is saying is I'm on VM2, I want to connect to VM1, and I want to use my VM2 user. If I try to do this, it's going to ask me for a password. It's going to give permission denied, and that's because this account doesn't exist. And the reason I'm going to go through these kinds of examples is because I really want to hammer home context for when we get into this last portion dealing with the local and remote forwarding. If I specify a user that exists over there, now we can move in. Okay, I'm going to hop back out. Now there is an option here that you can use SSH to connect, run a command on the remote machine, and then disconnect. And one of the reasons I wanted to highlight this option is because when we think of someone logging into a machine to run commands, we think of them actually moving to the machine, staying on the machine, and running the commands there. And I wanted to emphasize this because that's not the only way that commands can be run using SSH. So SSH would make the connection, but we can also pass commands to the remote machine. So what this is going to do is we're going to connect, we're going to authenticate. Once that is authenticated correctly, it's going to run the hostname command. It's going to display on my local machine, nothing happened on the VM1 machine, and then it automatically disconnects. Okay? Now, let's see, where are we? Nothing there. We're going to do info.sh. I've got a quick script that we put together. Take a quick look. Basically just going to give the host name, going to do the IP, and some fanciness around it because it looked cool. There we go. Info. Okay. So if I run, it gives me VM2 and it gives me the IP address of what we're doing. So here's what we're going to do. There is, when I was doing some research into the different configurations that SSH could do, I stumbled across this, which I thought was really neat. And I wanted to pass this along. This is one of those areas that I cherry-picked for the purpose of demonstrating the different types of functionality that SSH could provide. Well, it's a combination of bash and SSH technically, but we're going to use it with our SSH shell. So what this is going to do here, we're going to connect. We're going to use VM1 user. We're going to connect. Now, we have a bash-s and a double dash. So what this is going to mean is bash-s, this is an option that if there's no arguments that are passed after this, then any commands that are read are going to come from the standard input. So right over here is where this is going to take place. And then the double dash is just, that's another way of saying stop all options. No other options can proceed past this point. So you've got bash-s if you provide no options, and you can do a double dash to prevent any further options from being read. And then what you do is you provide your input, what you want to run. In this case, we're going to run a script, and it's going to do the same thing as this up here, just a little bit more complicated. We're going to connect, we're going to run this remotely, display the information locally, and then it's going to disconnect for us. And the reason I bring this up is because if on your system you have networking, you have logging, you have monitoring, network logging, monitoring, sorry, I'm getting my words mixed up. You may see a brief connection. This only took a few moments. You may see a connection where someone connected, 2 seconds later they disconnected. And unless you know that things like this are possible, things like this are doable, you may think nothing of it. But if you start seeing lots of these connections where they connect them back, connect back, depending on the verbosity of whatever your logs are, then it may be something you want to look into for, is something like this happening? So just some functionality to be aware of. Okay, I think that hammers that one pretty well. Let's see, how are we doing on time? We've got about 10 minutes. Here's what I'm going to do for this. Because of some time constraints, I'm not going to actually walk through the SSH-ID copy, the ssh-copy-id and the ssh-keyscan. I'll give you a really quick overview of what they do, and then we'll move on to the actual local and remote forwarding. So for ssh-copy-id, this gives you the option of, if I'm on my VM2 machine and I've created my key pair, this will let me push my public key out to the different machines that I want to connect to. So I can take my public key, I can use the ssh-copy-id to copy it out there. Now I could just copy the contents of the folder and I could log into the other machine and paste it in there and create the file manually, but you have the option, SSH provides the option for using the copy-id function, and that's what it's there for. You'll specify the -i is the path that you want to put to your public key, and then your basic information for when you connect. Now the keyscan is a little bit different. This is where you can enter a range of IPs. You can enter a file of IP addresses, and then you can do an ssh-keyscan, and that will go out and that will reach out to each of those IP addresses, and it will come back and populate your known host file. Well, I should say it'll display it back, and if you pipe it into, or if you output it into, append is the word I'm looking for, if you append it into your known host file, this will take all of the IPs that you specified, whether through a file or individually, and that'll put those public keys into your known host so that when you connect, you don't have that fingerprint pop-up that comes up anymore. So I was going to go through that, but that's something that you can do in a lab fairly quickly. And probably similar with SCP. Now, I take that back. I'm actually going to take a moment here with secure copy, because I want to look at two things. So the process, or I should say the syntax for SCP is the SCP command -R will allow for recursively for folders if you've got a directory, for example, that you want to copy from one place to another. And then the format is give me the source, give me the destination. And we're going to do an example very quickly with our VM1 and VM2. So, SSH. Let's do this. Let's make ourselves a directory. Let's make a test folder here. cd test folder. And the good news about me creating my command files, there we go, got all our files. I can just copy and paste and do this a lot faster than trying to type on my laptop. All right, so source and destination is how this is going to work. cd, let's go back a directory. Here's our files. Now, one thing to note while I'm looking at the SCP information is SCP is a remote copy file program. I want to highlight that this uses SSH. This uses SSH to transfer the data between those hosts on your network. So the same authentication that's used in SSH for your security is also used in SCP. So if you have to transfer files between systems, this is a very good way to do it. So here's what we're going to do. We're going to take SCP, and we're going to take our source, which is locally. We're going to take our destination, and we want to put it in the, right now there's nothing here. We want to put it into the VM1 user. Actually, I take that back. Let me go back up and sudo VM1 user. Make sure we're in the right place. Okay. Now, we're going to use SCP. It's going to authenticate. If I can type the password correctly, we've got a transfer, and now we have a secure transfer of a single file. And this is going from our local where we typed it to our destination. So to use an example with our -R, -R is where you're going to have a directory with its contents inside, where you're going to recursively go through a folder and the contents of it. So exact same formula, where you've got SCP, you're going to have your location, which is our local spot here, and then the destination where we want to put it. We got the individual files. There we go. If we go cd test, we've got all of our files inside of that. So I'm going to flip this around real quick, and I want to make a note between going from local to remote, which is our first example here, from local to remote. Now I want to pull from a remote location, pull it to my local spot. What's going to happen is your source and destination format is going to be in place. It's going to be the exact same thing. Let me copy this so that I don't have to type it out. And make sure that I'm in the correct directory. And let's walk through this. You've got your -R. Now our source, rather than being local, is now going to be our remote location. So you're going to have the user at the IP, there's a colon, and then for your path, you're going to have slash whatever path that this file is at. And for this case, we only want to pull the star.html. I'm going to expand this just a bit so you can see the entire line here. So we've got our address, colon, we've got our, this is the location, this is the source of our files, and we're going to take only, with our wildcard, only the HTML files, and we want to use the dot and put this where we are right now. So we're going to put this in our local directory, or in our current directory. There we go. And you're going to use the same thing, VM1 user. It says 2 files were transferred instead of 3, and if I do a search, there we go. Only the HTML files were copied from remote to my local directory. So very, very quickly, that is an overview on using secure copy, local to remote, remote to local, and the 3 main ways that you would use that, whether a single file, an entire directory, or if you want to specify specific files or types of files within a directory. Okay, here we go. We're going to run a little bit late, so I apologize for going over, but this right here is where I wanted to spend some time. Okay, so we're going to deal with an example of local port forwarding and remote port forwarding. So local or reverse, whichever way you want to look at that. Now, initially I was going to map this out on a diagram and make it all nice and neat, but the whiteboard worked better for me, so I've got a snapshot of the whiteboard. So let me walk through what we have here and why I'm saying that context matters. We're going to have 3 machines, and this is going to look very similar to our A machine, our jump host, and our C machine on a separate network. If you compare between the syntax, between the local and the remote, they're very, very similar. And what I've done is, when you create the tunnel for a local session, you're creating that on your, I'm going to use A as my local machine, just so that we're on the same page. A is where I'm going to stand locally. B is going to be our intermediary, that's going to be our jump box. C is going to be our destination. So that's the format that I've got this set up as. And I figured this was the best way to be able to demonstrate that. So for local, on your local machine, you're going to set up your tunnel. You're going to use a -L for local. You're going to bind this to your A machine, port 8022, whichever open port that you have to use. You're going to put a colon, and you're going to specify the destination. That destination is going to be your C machine on an open port that'll accept the data. And we're using an SSH connection, and we're using a terminal to be able to connect with SSH, so our destination port is going to be port 22. So we're looking to connect from A to C, going from 822 on A to port 22 on C, and we're going to put B as our device is going to pipe this through. Now on the remote, it's going to be very similar. You're going to have an SSH-R. You're going to bind also to your local port 8022. You're going to set your destination IP and port, in this case port 22, but this case we're going to use port A because this tunnel is created remotely to our local machine. You'll notice that this tunnel was created on machine B, whereas this tunnel was created on machine A. Okay, once we're on machine A, we'll run our SSH, we'll connect to our local machine, port 8022, and we'll go across. When we set up our remote tunnel, we're going to do the same thing, SSH on our local machine to our local host, port 8022, and we're going to push across. Okay, so this is where the fun's going to show up. Let's do this. All right, now I'm going to, we're at VM1 user. That's where we want to be. Let's USU VM3 user. Okay, who am I? Good. And I am on purpose making sure that each of these is logged in for user with individual user accounts so that we can see not just the network connections, not just how the tunnel is created, but where the access takes place and what the permissions are that you need. So which one are we on? We're on VM2. VM2 user. All right, let's walk through an example here. So if I'm on my VM1 and I want to set up a local forward, I would use, this is my local machine, VM1. This is my VM4 machine, IP address, and using port 22 here. Now you notice I'm not giving it a name. I'm not saying username at 77.53, which is right here. Remember, we have two interfaces. The 7753 is bridging, this is bridging between the A network and the B network. So here we go. Let's set up our tunnel first. We're going to get our fingerprint. We're going to put, you notice it's looking for VM1 user on 7753. That user doesn't exist over here. So this is why I'm doing this. I'm going to do a couple of these intentionally like this so that we can see what the connection looks like and what the credentials need to be able to come across. Okay, so let's grab an updated. So now we're using the same command, except now we're using VM3 on this device. It's going to look for VM3, which we have. Let's make sure I type that in correctly. Did I type it in? Aha, I did type it in. So, host name, who am I? All right. So SSH, my user, that's 192.168.51. Yes. If I can type correctly, and bingo. All right, so this is where, if I'm now on VM1 and I do a netstat, it's not copying. Oh, there we go. We're going to see that I have localhost on 8022. So let's do this. So now that the tunnel is created, we want to connect. If I'm on VM1 and I connect locally, let's come back over here. If I'm on VM1 and I have my local tunnel created and I want to connect from VM1, that's going to take a minute. Let's do this. I did it again. There's a copy-paste issue between my notepad and my window here. All right, so SSH, I am purposely not giving it a username. And this is looking for VM1 user at localhost, which for all intents and purposes looks good. But when I supply the password for VM1 user, we get a permission denied. And here's why. If you look at the tunnel you're creating, when you connect locally here, your destination is not going to be VM1. Your destination is going to be VM4. And so when it connects between 8022 and port 22, it's actually looking for the destination user password here. So if I put my password for VM4 user, which is different than VM1 and 2 and 3. Now I'm in. Who am I? VM4 user. Okay? So let's close this one. That is a real quick example of our local report forwarding and the different pieces that go with it. So we're going to do one more example here with our remote forwarding. Did I say local or remote? Last was local, this is remote, if I misspoke. So same basic format. Now we're looking at port 8022. Now again, context matters. The remote tunnel is created on a machine remote from my local, if that makes sense. We got a remote 8022, same format, and this time I'm not providing a user again, but this time we're connecting to 77.51. It's going to ask, and it's going to say VM3 user, because again, it's going to take whatever our default is here and assume that that user is going to be on this other machine, which is not the case. Again, I'm doing this on purpose just to hammer it home that the context, when you not only create the tunnels, but when you try to connect to them, that matters. All right. There we are. So now we have our tunnel, and since I'm already on VM1, which is where I want to connect to anyway, if I do my netstat, and look for 8022, I'm going to see a little bit different now. I'm going to see that this is bound to all interfaces on 8022. So let's see what happens. If I try to SSH, password 1, not gonna work. But if I use my VM4 user, again, for my destination, we're gonna end up connecting through. There we go. Okay, so real quick, hopefully able to pick apart some of the different pieces of that. And speaking of root login, I had another piece here that I wanted to bring up. That if I've got a connection such as this, and I decide that I want to say, I want to secure copy, I know that I have access to this machine and I've got the remote machine. I want to land on that destination. I want to head over there. But first, here, let me do this because this is where I want to be. I want to get back down to my Vagrant account because that's an account that's shared across multiples here. Let me set up my remote one more time. We're on our jump box. We're actually going to take the username out because if I'm using an account that's shared across multiple devices, chances are that password is the same on every single one of those devices. Ah, look at that. So it is. There we go. And if I'm over here on VM1 and I say I want to copy the changes that I've made to this ssh config file and I want to push it through to my destination, and oh look, it's the exact same. This one is asking for root access. So one thing to note that if that PermitRootLogin had been turned off, remote root access would not be allowed. And for changing some system files, root access is needed. So I wanted to pop this up so that this is something that you're aware of. If you've got the root account, you can copy that. You can even copy the ssh config file. Okay, so that is where we're at. Leave this up for one more minute, so if anybody wanted to pause it later on when we get the recording going. No problem, Stan. Thanks a lot. My battery is running low. Oh no, you know what? I was readjusting and I did not plug in my power cord. Let's fix that right now. There we go, that's better. I've got juice. Okay, so real quick, just trying to pick apart not just the pieces of the tunnel itself, but also the context on where the tunnels are created, where you have to connect from and to, and then what accounts are needed when you're starting to look at the whole picture on how those. Now this is a very basic example of local and remote forwarding. You can actually chain these together, which gets a bit more complicated, but for what we're looking at, this should help at least, if anyone's looking at this for the first time, to help wrap your head around where these connections take place, how those are made, and then what the pieces are and how they work together. So later on, we'll have some questions and comments. I know we're running a little bit over here, so I'm going to put some additional resources, and you're going to notice a lot of man pages. There's a lot of manuals out there in Linux for looking through your SSHD config, for your host's access. I would say if you're looking at a specific piece of functionality, read through these. There's a ton of information in them. There's a few links. ssh.com has some good information. I very quickly found one for configuration. It's not comprehensive, but it has some information out there for you with the Ubuntu help community pages. So with that, we're going to say thank you for just a minute here. Man pages, manuals. So if here we go. There was a comment saying, what are the man pages? I will demonstrate because demonstration works well. So if I wanted to look up more information on SSH, type in man SSH, and it will bring me up with a manual of the different types, the different options you have for using SSH. There's a lot of information as far as the different switches you can use, your bind address, your ports if you want to do, in this case, a dynamic port versus a local or port specific. You could do man SSHD, which would bring up a different manual for you to look at. And that would be why. Take this and just look through each one. I tried to map out all the ones that dealt with the contents of the things we looked at today. Yeah, documentation, got to love it. Gotta love it. Okay, so we're gonna say thank you for just a minute and we're gonna pause, but we will be right back. And I'm just going to give a little bit of information about the Vagrant file that we used, a little bit of information about the lab setup we did, and later on, if there's any interest, let us know. We'll see if we can't provide those in some way so that people can spin up either a similar networking environment, a similar lab, or if they're just interested in what the configuration file looks like. So I'm going to pause for just a minute. I will be right back. I'm going to give it 1 or 2 minutes. All right, here we go. Okay, so let's exit this, and I'm gonna put that away for a minute. Okay, so this shouldn't take too long. Let's clear some of this information out just so that we have a clean space to work with. Okay, so let's, if If Mike is over there, he's going to give me grief about using Notepad, but that's okay. I can handle it. All right. Let's see here. Okay, so in a nutshell, SSH, and Alex will be able to give far more detail about this because he's the one that actually got me involved on this, because we were looking at a nice way to be able to spin up a quick environment. We were able to create a lab, build it, configure it, put it how we wanted to use it, tear it down and build it back up from scratch again, all in just a couple minutes. So I'm going to hop out of this, and I'm going to make a quick note because this was shown to me, and so I'm going to pass this on to somebody else. Hopefully it'll be helpful. When you run a Vagrant file, which is what we've got here, you need to run it from the location that Vagrant file is in. For example, I have another machine up here which has a different Vagrant file, and I have another one up here that has a different Vagrant file. And so when you run it, you're running this configuration. And so when you start it up, you want to run it from this location. And a neat little trick is, if I navigate in my Windows Explorer here, and I type in PowerShell, it will pop me up a PowerShell prompt already in that location. So a handy little trick I didn't know about, but if anybody else does, great. I didn't know, so I was happy to pass it along for somebody else in case they're interested. Okay, so here's what we're going to look at. What we've done, and again, Alex, thank you again for all the help that you put into this, because I was in learning mode and I learned a ton just by going through this exercise. So here's what we've got. In a nutshell, we've set this up so that we're going to use an Ubuntu image that's on the Vagrant cloud. Can I make this bigger? I will try. Ah, look at that. To answer your question, yes, I can make it bigger. Let's make sure that gets across everything. Is that good, or do I need to make it any larger? Is that sufficient? I'm going to go with yes, since, okay. So we have an image that's on Vagrant Cloud that we've pointed this to, and that's going to be our default location. That's going to be the default place where, make this a little bit, okay. This is going to be the base image that we're using for our machines. Now the way we've done this is that we can set this, remember how we had VM1, VM2? I can change this to 1, 2, 3, and 4. I've set this up so that you've got a range of multiple VMs, so I can set multiple VMs on this network, which you're going to have your naming convention here, VM1, VM2. You're going to have your IP scheme here, 51, 52, 53, and so on. You're going to have host name, VM1, VM2, so on. We've allocated the amount of memory for each one, not a lot, but for your test machines, you really don't need a whole lot. And we're going to be using VirtualBox for this. If you only want to spin up one, you could spin this and do one-to-one. That's a valid, syntactically correct statement that will create a single machine instead of two, if you're just futzing around with it. Okay. Also, we've got some provisioning in here, and I'm going to look at this so that when we create it, we've got the usernames that get created, we've got the usernames that are added if needed, and the passwords, which would be VM1 user, password1. You can change this to whatever you feel like you need to. Setting a root, and we're setting the option to do an SSH prov. I'm going to come back to this in a minute because this was something that Alex helped work out at the end of all this. We were looking at ways to change our SSHD config file on the fly. So number 4 and 5 is the same. You can change these numbers if you want to create different ranges with different IP ranges for this. This one is a .78. Same basic information. For our jump box, we did this as a static machine. So we've set 2 specific IP addresses. These are just hard coded in, one for each network, public internal, in order to match these up here. And then if you had some configuration changes you wanted to do inside of Linux, if you wanted to say set a Dropbox path, or you want to set a different path that would configure something inside, there's another option here that you could use for that. So I don't want to go into too much detail of this, other than to point it out that we can provide this, so if you want to spin up a quick test lab, you can do that. I love that word, laboratory. Okay, anyway, the contents of this particular script. What we're doing here is we're looking at our SSHD config script for each of these machines that gets created. When each one is created, there's a provisioning process that happens. This script will get run. This is where we're setting our root login to yes. We're setting our password authentication to yes. And we're using a regex and some sed commands in order to go in and look for, is it there? If it is, uncomment it and give it this specific value. Now, let's pull up my VM2 for just a minute, and let's go to, let's see, SSH, SSHD. Let's pull this up so we can see the details of this. We're looking at root login is yes, password authentication is yes, permit empty passwords, yes, TCP, yes. Okay, these are all set for yes for right now. Now you can also add these other options in here if you wanted to expand this array. If you wanted to add to this list, you could do that. And here's where this comes into play. For example, as I was going through to really map out what each of these do, what each of these different options do, here, let's log out of these, kill my tunnel. That one's already out. And which one am I missing? This one. There. Okay, so Vagrant, here's the status of all the machines that I have up. It looks like I have number 5 running, but I didn't actually connect to it. So those are the boxes that I've got. So if I want to make a change, here's what I'm going to do. I'm going to do a replace. Let's change this from yes to no. Let's find the next one. Replace, 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 replace. Close it. Save it. Minimize. Let's do Vagrant provision. That is going to run through this provisioning checklist here. So there's going to be 3 provisioning steps for each of those machines. And you're going to see VM1, provision, 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 3 times. VM2, same thing. And with a short amount of time, I can pull those all down, bring them all back up. Prep my VM2 real quick, because I like to plan ahead like that. Okay, so let's go to VM2. Use a Vagrant SSH to get into my VM2 box. Clear, and let's do cat. My keys. SSH. So now when we come through here and look at this, we're going to see that my root access is set to no. We're going to see that my password authentication, permit empty passwords, all of these options that I specified are now set to no. So just an option that I can do when I'm bringing this up, pulling this down. And where this comes into play, let's get back into my jump box. Let's get back into VM1. I don't need to get into VM4. We're going to set up a remote session again. So remember before we talked about having those options set to no will not stop the tunnel from being created. I'm on my jump up. Hold on. It will, because I I changed the wrong options. See here, where I've got my password authentication set to no, now I can no longer use my public key. Now I have to use public key authentication. Let's set something here. I'm gonna reset a couple options just for a moment. I want to. That should be good, because that will interfere with what I'm trying to do here. Let's reprovision those. And this will be the negative example to the positive remote tunnel example that we did earlier. And I'm going to use the remote shell or the remote port forwarding just because it's self-contained and I can use one screen for it. Okay. So now let's try this again. We should have, this is no, these are yes. Good. So if I set up my remote tunnel using my Vagrant shared account across all the machines. So the remote tunnel was just created. If I do netstat-an grep4 8022, you're not going to see anything here. But if I try to do, where's my SSH? Let's do my SSH. So if I try to use that tunnel, connection is going to be refused. If I try to specify the username, connection is going to be refused. If I were to have the gateway ports turned on, but my TCP forwarding off, then I would get connection reset by peer. It would allow it to connect, but it wouldn't let me actually do a connection through there. So here, by having just that TCP turned off, the tunnel can still be created, but I can't access it from anywhere. I can't get to it from here. And so that right there really is just a few things that you can do with Vagrant. We can probably provide this in case anyone wants to use this to spin this up. So again, thank you all for the time. Thank you for logging in. Thank you for listening to the webcast. I hope this was useful. I hope this helped to untangle some of the local and remote forwarding concepts, as well as the specifics involved in the context of where things are being connected to. So thank you very much, and I hope everybody has a great day. Thanks, and we will talk to you after a while.